most significant ones. So to review, the antigens in the APO system are A and B. Remember, O is kind of a non-specific base antigen, the H antigen. For the most part, your APOs have a real strong IgM component. They cause severe transfusion reactions. These are your fatal reactions. Usually very mild hemolytic disease is the big one, if at all, because it has trouble crossing the placenta. It goes on to say usually it's more common in moms that are type O than type A babies. Occasionally type B, but the most common, for whatever reason, is type O moms, type A babies. There's that A comma B that O people have that can cross the placenta. And like I said, in blood bank, you'll learn to cringe. As soon as you see that mother is type O, you're already thinking, I'm going to have a positive DAD. Pretty sure that down at the bottom, characterized is probably not a word.
What is?
Characterized.
Yes. Characterized.
Huh?
There we go. Yeah.
Don't write characterized.
Tips
So
on
the
that.
RH system, really the first 5 is what you need to know. D for the most part. Big C, big E, little e. F is can also be present. Then the CW, V, G, etc. There's upwards of 70, I think, RH antigens. We really care about those big 5. Majority of these are IgG, which means they are significant, with the exception of D. D is kind of a split, but it does have a lot of IgM, which is why it shows up on immediate spin when we do a blood dot. Yeah.
A's and B's are IgM.
A's and B's are IgM. D is majority IgM, but it does have a small IgG component, and that's why it's such a big problem for the babies. The C's and the E's are primarily IgG, which means you're not going to pick these up at immediate spin. These can cause severe transfusion reactions, severe hemolytic disease in the newborn. Most of them cross the placenta quite well. Hemolytic disease in the newborn caused by RH antibodies other than anti-D do occur, but they're not as common. Because our most common occurrence is the anti-D. So the major blood group systems we're going to talk about. Lewis, I, P, M, N, and S group. Kale, Kidd, and Duffy. And the first half of that, believe it or not, we don't even care about.
The first what? 3? We don't care about Lewis?
First 4 for the most part. Those are our colons.
Okay.
We still care. We got to know them. Sometimes they cause problems. They're not our biggies.
The first 4 are the colors?
First 4. Those bottom 3, that's our biggies.
Question.
Yo,
You said the first 4 are colors?
colons.
Colds, got it.
Which means they're more of a nuisance than anything. They rarely cause actual problems. They cause wrong for us in blood bank. The last 3 are very significant. Some of the minor ones, Lutheran, it'll pop up occasionally. LW, you remember what the LW one was?
That's when they renamed it.
Yeah,
Man.
that's what they thought was the D antigen, but it was really a different antigen with the rhesus monkey thing. Then they renamed it in their honor, LW. Cheeto and Rogers, which I've never seen. You also have Bell, Gregory, Sid, Garbage, Swan, Livesay, Newfoundland, blah, 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 blah. Again, there's hundreds.
Oh my God.
No, you don't need to know these. That is for your information.
One of those is a dog breed.
Of all of these,
Newfoundland.
They're right.
Lutheran,
Groups.
you know a little bit about Lutheran,
Group, look out.
but it's very rare. The rest of them is just kind of FYI.
Support
And not as
system.
calling was they grew up.
Gorp.
Huh?
Oh, my bad.
Wrote the PowerPoint?
Yes.
It's supposed to say
Harold Spargo
Yeah,
or
okay.
before?
Okay.
Why?
Group.
Gorp.
Board.
Gorp? That's a special name for blood groups.
Gorp.
Call them Gorps just for significance.
Gorps.
Please don't tell me things like this. I will end up believing you.
So what makes something clinically significant? any antibody that can cause decreased red blood cell survival is significant. If it's gonna attach and cause no problems, then what do we care if it attaches to? But if it in any way, whether it's immediate lysis or slow lysis of those red cells, then it becomes a problem for us, causing transfusion reactions and hemolytic disease in the newborn. Not clinically significant, the opposite. If it doesn't destroy red cells or shorten their lifespan, we don't really care. Cold reacting antibodies, agglutination best observed at or below room temperature. Those immediate spin ones. Warm reacting, agglutination best observed at 37. Colds are typically IgM, warms are typically IgG. When people are trying to identify colds, they'll actually incubate in the refrigerator to make them stronger. Very, very few places still do cold IDs, because we don't care. But there are a few places that still want to know what that cold is. So the system's producing cold reacting antibodies: Lewis, I, P, M, and N.
Lipman.
Lipman. That's the easiest way to remember it. There's actually a slide in the back that says Lipman for the colds. Remember Lipman. Lewis is weirdo. It is a soluble antigen produced by tissues and found in body fluids. It is adsorbed onto the red cell's membrane. This is not something that's formed there in red cell production. Remember back when we were talking about secretors versus non-secretors?
Yes.
Secretors produce Lewis substance. Lewis substance floating around the body finds a red cell, sticks to it. It's like a pseudo antigen.
Okay.
So it is not inherent in the red cell membrane. But we detect it as if it was an antigen. Yes.
What does the word adsorb mean?
Adsorb, added to.
Jason.
Yes.
Is anybody else? Anybody else able to be a secretor, or only the Lewis?
Well, people who have that SE gene are secretors, and as a result produce Lewis substance.
Okay.
That's what they're secreting,
All right.
among a few other things.
Sorry.
No problem. So the Lewis system depends on the H, the SE, the secretor status, and the Lewis genes. You have to have all of them. Little Lewis, little h, little SE do not produce products. Remember, little SE means they're not a secretor. If the LE gene is inherited, either hetero or homozygous, Lewis A substance is produced. If all of them are inherited, then your body will convert Lewis A to Lewis B. So you can see this one only got A. This one inherited all three of them. So then it converts to B. Occasionally in babies, very early on, they're not producing any of this, but it takes time for them to convert. So briefly, they'll actually be Lewis A positive, Lewis B positive. It is exceedingly rare for an adult to keep both. Because you're either going to be Lewis A or your body's going to convert it to Lewis B. It's exceedingly rare to have both. And you can see this one is not a secretor. Negative. This one is not a secretor, but notice it says this is very rare. Why? What is the little h, little h? Bombay.
Bombay.
You've got to have the H antigen to have a blood type. If you're little h, you're Bombay. You have no blood type. So as a result, that one you'll never see. The one you see is this one, Lewis B positive. Most people are Lewis B positive. This is another one of those charts where, and I understand why they don't, but I wish they would put race on the blood bags. Because there's a disparity in the race between percentages. That would actually help us grabbing units to cross-match to give us better odds.
Oh.
I very much understand why they don't do it. Even though it's backwards and ridiculous, but I still get it. Lewis antibodies can be a naturally occurring antibody. They can occur naturally in those who are negative for A and B, which again is not very common. The other phenotypes very, very rarely produce an antibody. It's typically IgM, and it may fix complement. What a complement's job is to lyse red cells. So in that regard, it can become hemolytic. It can be problematic. May be detected soon after pregnancy because pregnant women may temporarily become negative for both, which is a weird phenomenon. Has no clinical significance. Lewis antibodies in a patient can be neutralized by the Lewis antigens on the donor plasma. They will cancel each other out. They do not cause hemolytic disease in the newborn because they do not cross the placenta. Antigen typing donor blood for transfusion is completely unnecessary. You'll do the IAT cross-match, you'll take it through all three phases, and that's sufficient. If it doesn't react at Coombs, it's gonna be fine for the patient. And that really doesn't matter for the most part which antibody we're talking about. If your cross-match is good through Coombs, you're in pretty good shape. So the biggest thing you need to know about Lewis, 90% of the time it has no clinical significance whatsoever. It's another cold that causes us problems. There are two, big eye, little eye. Newborns have little eye. They will usually change over to big eye in the first 18 months. Most adults have big eye antigen. Rare as an adult, little eye. So you think most of us have this antigen, then we wouldn't have antibodies, it wouldn't be a problem. Well, there's a problem that goes along with it. Most people have an auto anti-big eye. One of those auto antibodies, a lot of people, when we're showing these codes on our screens and stuff, that's one of our big culprits. That's one of those that shows up, messes us up, and we just warm it up and we can make it go away. Cold reacting IgM, so it's clinically insignificant. It's a nuisance. Can attach complement, can be a little bit problematic there. Pre-warming the test can completely eliminate reactivity. I don't care that enzymes enhance detection because we don't want to detect it. It's often found as a compound antibody with H, which means people who are type O tend to react stronger because they have more H. Our job, again, in the very last line, most important line on this page, our job is to eliminate colds. Because what they do is they make our life difficult and obscure significance. And these are insignificant. Have y'all ever heard of cold agglutinin disease?
Yeah.
Where people can actually, in cold temperatures, where the tips of their fingers and all that turn white, they'll actually clot off, like almost similar to frostbite.
Right.
Yeah.
These people, a lot of times this happens older people, later in life. There's a reason so many old timers retire to Florida. This tends to crop up later in life. Move to a warm climate.
My grandma's doctor recommended that actually.
This is also a problem. Mycoplasma pneumoniae. We'll talk about this more in micro. This can actually produce the anti-big eye to give us this cold. What is Mycoplasma pneumoniae? You ever heard of walking pneumonia?
Mm-hmm.
That's it. That's the causative agent of it. Walking pneumonia is fairly common. They call it walking pneumonia because you don't feel bad enough to go to the hospital. You walk around with it. So it's a very common illness. A lot of people have this as a result. Anti-little eye, again, it's rare. That one can be associated with infectious mono. Anybody in here ever had mono? I had twice. I have an anti-little eye. But again, the last line, eliminate colds so you don't have to deal with them. If they crop up, warm this stuff up, make it go away. P, here's how much I want you to know about P. It is similar in structure to the APO system. There are subgroups of it, kind of like type A. You have P1, P2, got several of them listed. What I want you to know is that it's similar to the APO system. It is a cold, it is a nuisance, it is insignificant. That's how much you need to know about P. Here's an odd thing. The P1 antigen, strength of that antigen will decrease upon storage. So that unit of blood that's been in the refrigerator for 3 weeks, it'll weaken at the point we almost can't detect it. The cool thing is though, something you'll learn in parasite, the height of the tapeworm cyst, it forms a big cyst in the body, produces P1 antigen, pure P1 antigen, purer than we can form in a factory. Poor dog doesn't look real pleased about having that tapeworm. And it's actually been known to be fatal when one of these cysts rupture because it floods the body with so much of that and everything in your body just glues to a halt. So don't get tapeworms from your dogs. The antibodies to these, the only thing you need to know is that auto anti-P is what caused that paroxysmal cold hemoglobinuria. Remember that from hemo?
Yep.
Get cold, hemoglobin in the urine. The auto anti-P attaches complement when you're cold. Once the red cells start circulating, they begin to lyse, etc. That's your causative agent, anti-P. The M, N, and S group, M and N are colds. And no, I don't really care about the glycophores. They're colds. They're a nuisance, they're a pain, they get in our way a lot. S is a little bit different. You'll never see or hear of again, but it is part of that group. All of these can show dosage. Remember dosage when they're inherited heterozygous, where you have both M and N, they react weaker than it would if you just had M. S does as well. They show dosage, but they're cold, so again, we warm it up, we don't care about the strength of reactions.
Question.
Yes,
The M and N are cold agglutinin antigens.
18.
they're cold. They're colds. They're cold antibodies, IgMs.
And S is also a cold antibody.
S tends to be more IgG, and that's why I said it's a little bit different from these M and N's, but they're in the same group, they're in the same family. These, a little bit different in race as well. No, you don't need to know the race disparities. Most of your antigen charts in the hospital that's hanging on the wall in blood bank, they'll tell you the race disparity, but it doesn't matter. It doesn't tell you what race the unit is. That's why I wish it would. So M and N are IgM, which means they're cold. They are rarely IgG. They do have a small IgG component, but we're talking about 90%, 10%. So very rarely a problem. Clinically insignificant. If someone was really weird and had a large IgG component of that, it would be more significant maybe. That would be extremely rare. Big S, little s, they are clinically significant. They have a much larger IgG component. They can cause red cell destruction and hemolytic disease of the newborn. Anti-U, what you need to know about that is if somebody has that, you're really gonna have problems. You're gonna have to contact Rare Donor Registry to find compatible units, because that one is such a common one. It said your best bet is in the black population, and even then it is less than 1%. So ABI, if you need that, ABI is gonna have to screen thousands upon thousands of units to find you a couple. Again, U, don't really care that much about. S, you do need to know about because they are significant. This little cheat sheet, quick, easy, clinically significant. M and N, no. The rest of them, yes. So these are the ones that cause us the most problems because these are clinically significant. These are the ones we are trying to detect with these colds messing us up. We're going to start with the KEL system. There are two major ones. It goes on to say that there are over 20. Big K, KEL, approximately 9% of the population positive for Big K. The book says the correct term is capital K, not KEL. Every blood bank tech is going to call it KEL. Some of your older blood bank techs still remember these terms, and little k was known as Solano. Because it's easier to say KEL and Solano versus capital K, little k. So that shorthand was done a long time ago. This was the first antibody they discovered after they come up with Coombs. Because that's how common it is. They are co-dominant. They are well developed at birth, at least the antigens are. And the big K antigen is very immunogenic. It is second only to the D antigen in being able to make someone produce an antibody. So other than anti-D, big K is your most common antibody you will encounter in the blood bank. Luckily, it says that only 9% of the population is positive for K, which means it's relatively easy to find compatible units. I mean, 91% are compatible, so it's not too bad. But it is a very common one that pops up. Other KELs, the KP antigens, KPA, KPB, were named Penny and Rottenberg. You can see Penny is a very low frequency antigen. Less than 2% of the white population is positive. That's significant because when we do our antibody panels trying to ID stuff, most of the time they're all negative for that. It's hard to find cells that have that on them. Whereas KPB is a high frequency antigen. 99.9% of the population is positive for that, which means when you look at your panel, every cell is positive for that. You have no negatives. So if that was truly your antibody, that was your problem, your whole panel is positive, now it looks like a cold. So that's problematic. Luckily, exceedingly rare. I've never dealt with KP. I have had to deal with the JSs. JSA, JSB, Sutter, and Matthews, respectively. This is another one of those where putting race on the bag would be very beneficial because it's 20% in blacks, but only 0.1% in whites. So if someone had an antibody to that, I want to pull all the white units. You got a really, really good chance the first one you pull will be compatible. Matthews is another high frequency one. Shows up a lot as far as the antigen, not the antibody. KEL null or K0, you don't need to know much about. It just means no expression of KEL antigens. And it says if somebody does have this, you got to pull rare KEL negative units, which are almost unheard of. That's kind of like that rare Bombay or the rare RH genotype where they're like negative for everything. Exceedingly rare. We talk about the rare units of blood that they can freeze for 10 years. This would be those. Because when they find one, they're going to freeze it. Know that it exists. No, I'm not going to test you over KEL. kill antibodies, they are IgG. They react very well at AHG or Coombs phase. Usually give you a good, strong result. Produced as a result of immune stimulation, like most of our antibodies. You're not going to get this unless you've been transfused or you've been pregnant. They are clinically significant. They can cause severe transfusion reactions. Since it's the second most immunogenic, it's the second most common antibody that you'll see. You can scratch out KX. This is here for one reason only. No, you don't need to know this. But the JKs are codominant alleles, which is another one of those that can show dosage. They go together. Remember, the ones that go together can show a little bit of dosage when you're looking at your panel. If the cells are positive for both of them, it may be a 1+. If it only has one's positive, one's negative, you may get a 2+. The kids, they're enhanced by enzymes because they're not real accessible on the red cell membrane. They're deep antigens. So if we treat that panel with enzymes to remove that outer coating, this actually gets a lot stronger. I have no idea what those pictures have to do with any of this.
The kids.
Kids. Good point.
My boss.
The JKAs, JKBs, they are clinically significant primarily because they're a common cause of delayed hemolytic transfusion reactions, which is something you don't want to have to deal with. You give somebody a unit of the blood, they're great. Everything's fine. They go home, 24 hours later, they lyse all the red cells, now they're anemic again. How and why? They're not 100% sure. It's an overreaction of the body in churning out antibodies to fight this, but the body waits and thinks about it a little while. It looks at it, says, yeah, we're going to make antibodies tomorrow. Like I said, they don't really understand the how and the why of delayed hemolytic transfusion reactions. They just know that it happens, and they know the most frequent causes. JK3, if you care, is exceedingly rare. They find it in the Far East and Pacific Islands. Cool. Duffy. This is my nemesis. Cannot stand Duffy A. Yeah.
HT and hemolytic transfusion in.
Newborn.
HD in?
Newborn?
Hemolytic disease of the newborn.
No, HT in, hemolytic transfusion.
R.
Where'd you see HT in?
Oh, it says R then.
HTR.
Reaction?
Yes.
Okay. HTR.
Hemolytic transfusion reaction, HTR.
Thank you.
Delayed hemolytic transfusion reaction. Duffy A, Duffy B. Very well expressed at birth. Antigens are destroyed by enzymes. These will definitely show dosage. The most significant thing on this chart is right here at the bottom. 68% of blacks are negative for Duffy A and Duffy B. How many times I wish they would put race on those units of blood when I was looking for Duffy A, because Duffy A hates me. I'll screen 15 units every time I need one to find it. At least.
They're positive for it.
Other people can go in there and screen 4 and they'll find one right off the bat. It hates me.
It's very rare in white people.
Feeling is
68% of black people are gonna.
There is a reason why 68% of blacks are negative for both of these.
Oh wait, negative? Oh.
I'll tell you in a second. Leave that hanging. They are IgG. They will cross with the placenta. They're IgG, they're clinically significant. They are associated with both acute and delayed hemolytic transfusion reactions. They are associated with hemolytic disease of the newborn, and it can be anywhere from mild to severe according to the dose. This is another one, this is not naturally occurring. The only way you're gonna get an antibody to a Duffy is to get pregnant or get transfused. So why are African Americans, for the most part, Duffy negative for Duffy A and B? Because in Africa, the malarial parasite, which is so prevalent, will not invade red cells that are negative for both. There is something about that. Those Plasmodium knowlesi, that is like the rarest malaria ever. Plasmodium vivax is one we care about. They will not invade Duffy A or Duffy B negative cells. And they don't really know why, but it seems like they're thinking that that antibody has to be there for it to attach. This phenotype is found very frequently in West and Central Africans, supporting the theory of selective evolution. If you don't have those antigens, you tend to live longer because you don't get malaria. One of those weird things. They've also found in just recent years, though, that there seems to be some sort of help with the HIV virus as well.
Help with what now? I missed the HIV.
The HIV virus doesn't seem to like people who are negative for both either. They can still get infected,
But it's a lot
but
harder.
it's a lot harder.
Yeah.
Interesting.
It's a lot lower incidence of infection among people who are Duffy A and Duffy B negative. They don't really understand why, just like they don't understand the malaria thing.
Right.
It just is. Yeah.
Go back, the FY, it means Duffy.
Duffy. And there are
A
two of
minus,
them.
the A minus and the B minus.
Negative for Duffy A and negative for Duffy B. They have neither antigen.
The A is a subtype of Duffy,
Yep.
and the B is another subtype.
Yep.
Okay, cool.
When you look at your panel sheets, there will be FYA and FYB because they're two separate antigens. They're just related. Lutheran, never have I had to deal with Lutheran. There are two of these again, Lutheran A, Lutheran B. Most individuals have Lutheran B. Very rare would it be a person to only have Lutheran A, and very rare to be negative for both. They are split, IgM and IgG. It contains both, but very rarely are they a problem. They react at room temperature because they have a much higher incidence of IgM than they do IgG. If there's enough IgG there to cross the placenta, it's usually very mild issues with the baby. This one can be naturally occurring or immune stimulated. The Lutheran B is rare because it's such a high incidence antigen, but it is the more significant of the two because it has a higher amount of IgG. XG, it's the sex antigen. It's sex linked. Tells you that females inherit 2, males can only inherit 1. Because we only have one X chromosome. It's not a strong immunogen, not attributed to transfusion reactions, but if there's an antibody to it, they do tend to be the IgG class. So I guess the potential is there for it to be problematic, but it never is. I've never seen an issue with that. I'm not even gonna cover HTLA antigens. So codes, your Lewis's, I, P, M, N. Remember the shorthand, Lippmann. Naturally occurring. You don't have to be stimulated. What's that got to do with it?
He's thinking about
Lip.
lips.
Lip man, okay, I get it. That's the easiest way to remember your colors, remember lip man.
Hang on one second.
Take a picture of the last one.
Sorry.
She's like, I ain't gonna find this story.
Good. Sorry about that.
You're warm, RH, Kel, Duffy, Kid, the S's.
Oh, that explains the sun.
Warm.
No, on the previous slide, I didn't understand why there was a sun.
These have to be stimulated.
And the next slide, I really don't. Or maybe, is it the next slide?
The last one.
No.
So, yeah, the last one's getting me.
The very last slide?
Yeah.
Yeah, I don't like it
Um,
either. Here's a quick chart for the enzyme activity, the ones that are enhanced versus the ones that are destroyed.
What?
Remember, you
Yeah,
can
I
get
need the
enzyme
sunshine.
treated antibody panels.
Sunshine?
So when you're
Okay.
trying to rule something out,
Got it.
if you got a Duffy and something else, and you wanna get rid of that Duffy so you can figure out what the other one is, use enzyme treated, it'll eliminate your Duffy, and now you can start figuring out what your other one is. Yeah,
On the previous slide, the lipid slide. The third entry, is it anti-I or anti-L?
I, capital I.
Thank you.
Lipman.
This, I don't like, for remembering dosage, which ones go together, I don't like this one.
definitely the monkeys.
RH, rhesus monkey,
What?
eat lots of M&Ms, like M&Ms, that's why they're trick or treating, except for it's M&Ms, because that's our antigens.
Ah.
That's a Carol Spargo thing, I don't like that slide, it doesn't help.
The monkeys eat less.
And
Yeah, because I was gonna say,
That's
this
what
just
showed us.
confuses me.
I would have never picked
No.
up on that.
My recommendation is just write those down at the bottom,
She's.
those are the ones that typically show dosage on your panels.
I love her.
Kid, Duffy, your RH,
I never
and
talked to her.
But
M&S.
in no particular
Like
order.
Yeah.
No particular
We
order.
spent some time.
Well, yeah, there is a particular order for me. The
Yeah,
most
we're
common
taking this class
time
on
I've
Tuesday,
seen
Tuesday.
somebody showing dosage is Duffy.
I'm so happy.
Duffy's will show dosage big time.
Well,
And she
sometimes
just didn't know it was on there.
Duffy's my nemesis. I hate Duffy.
What does it
And she's
mean to show
always
dosage?
reading.
I'll
I love
demonstrate.
her because she shoot the skin. Which I'm passing shit. They tell me which area. I love that.
yeah.
With old people, that is, you know. Not the young boys, a bunch of me, and that's not what I'm looking for. Just like, oh, damn, girl, I didn't know that. I'm like,